So hello everybody, my name is Philip Ozil. I'm a developer evangelist for Salesforce, and I'm here today to talk to you about Node, React, and Source.com. And there's actually a little bonus here that doesn't fit on the slide. I'll also be talking about Heroku, by the way. It would be too long of a title to put that in, so it's another little addition. Before I start, something I've already seen a couple of times, I guess, here. Forward-looking statement: because we're a publicly traded company, do not make purchasing decisions based on what I'm going to show. My personal take on that is that all that I'm going to show here right now is already publicly available, so you should be okay. So let me go through the agenda for today. I'm going to talk a bit about what drove me here over at Dreamforce, of course. I'm going to explain a bit what are my motivations and my goal in sharing this session with you guys. I'm going to present a bit my work with a short demo, and then I will go down in how I architectured the application I'm going to demonstrate using Node, React, and Heroku. So I will present the different components one by one so that you can understand how they're architectured. And I will conclude. So first, why am I here? Well, I'm here, as I think, a bit like everybody, I'm here to learn, and I'm here to share my knowledge. So my original intent here was to learn React. I've been a big of a fan of AngularJS in the past, and I recently thought about learning React. So I took an opportunity to learn about React and to share my knowledge. And while I did that, I also wanted to have some connection to Force.com to share a bit how we can relate a React application with Force.com. When I drove on this journey to learn more about React and Force.com, I discovered that there was no clear path. There wasn't any documentation that went from the basics of learning React to using actually Force.com with a connection between both. So that was my main obstacle, and I think I overcome it. And I'm here today to share about how you can achieve such an application from the beginning, creating a front end, to driving it with a back end that is connected to Force.com. And I'm going to cover that with some really essential use cases, like performing authentication, retrieving user sessions, and running some SQL queries. These are really typical use cases you want to cover when you create such an application. Now, let's get forward and actually start by the final result, the application itself. So I'm going to open this. This is a Heroku hosted app. And this is the application I want to share with you guys today. Oops. Well, anyway, I did this application in React, and I also used for the styling the Salesforce Lightning design component. This is just a bit of styling. It's not Lightning itself. So what we have here is an application with a login screen. If I click on login here, we'll be redirected to a Salesforce page for authentication. This is not part of the application, but it is part of the authentication flow. So if I log in, I'll be entering the application. And here now I'm back to my application. So the application was able to retrieve my credentials and my my username, sorry. And I can also perform some SQL queries here. I've entered here really a simple query to retrieve a list of users. If I run this, it will perform the SQL query under my Salesforce Developer Edition. And I can see a couple of results there as JSON. So I'm not limited to this simple query. I could run whatever query I want. That's about it. And I can always log out to close my session and go back to the login screen. So this is the final result. What you see here is an application that was made with React. It has a backend also on Node.js. Now let me explain how I made this. First, I'm going to cover a bit of an overview about the architecture of this solution. How does it work? What are the different bricks I have to assemble? To create some application really similar to this, you have to think about several constraints. The first one is that it is a web application with a front end and a back end. The front end will be what is actually going to be responsible for the views. It will structure the user interface with some HTML, some CSS, some JavaScript, of course, React. And there's going to be also the back end. So we can have multiple technologies for the back end. Here I chose Node.js to have JS all around the front end and the back end. The backend is going to be pretty important here. It will store my session information, and it will be actually a relay that will allow me to authenticate with force.com. Talking about that, most of the challenge in creating such an application comes from the force.com authentication. There are several ways to authenticate with force.com. The recommended way for an application with a user interface is actually to have OAuth authentication. So OAuth is pretty much of a standard, but the problem with this standard is that each service provider that implements OAuth has a bit of freedom in terms of implementation. So Salesforce, among others, has its own implementation. So to authenticate with OAuth 2 and Salesforce, you have to follow the implementation of force.com. Another thing you have to do also is to create in your org a connected application. So I will not cover that part in details, but that's something you have to take in mind. So. And lastly, while I was at it, I created first the project on my own computer, and then I thought this needs to be on the cloud, because the data model is actually on the cloud. You have to have your application also on the cloud, or else there's no point in having just the data in the cloud. So that's why I added the last brick, the Heroku hosting. I'll get back to that later in the presentation. So now that we've seen that, let's see what are the different bricks in our application. First, we have the front end. So that's going to be using React. This is going to be JS, HTML, and CSS. Then we have a Node backend. So this is going to be the runtime. There's going to be HTTP server running for me. In this application, I use Express. This is one of the many HTTP servers that are available on Node.js. And I'll be communicating between those two components using REST. Pretty standard web application here. Then the tricky part is to have the force.com block communicate with our backend. So for that, we'll use two different ways, two different communications. We'll use the OAuth authentication, and we'll use also some REST queries. The REST queries, we're actually going to be using the force.com standard API. So we're going to be able, for example, to retrieve objects using REST APIs. And lastly, as I said earlier, the front end and the back ends are hosted both on Heroku. That is how to keep everything in the cloud. So my presentation is going to go into each of these different components, and I will explain a bit more how they are assembled and how they behave. Let's start with the front end in React. First, who already knows React here in the room? You guys are familiar with React? Okay, cool. That's great. So I'm going to go just quickly about this. It's not going to be a full tutorial on using React. For those of you who are not familiar with React, that's an open source JavaScript library that is created by Facebook. And it became more and more popular in these recent years as a viable alternative to AngularJS. AngularJS was a really good precursor. It was one of the most popular JavaScript libraries around. And at some point, they decided that it should have a version number 2, and that's when things turned a bit ugly in the community. So I'm not going to talk too much about that, but I think that really drove React forward. So right now, React is one of the most popular JavaScript libraries, I would say, to create applications. And I think the success of React is mainly due to the fact that it is very simple to use. It's really easy to learn it, actually. So I'm going to, oops, slight mistake here. I'm gonna present it a bit, but a few key concepts. How does React works? The way React works is actually by having components. So think of components as elements of your UI. You can basically take a view and separate each of the elements into components. For example, a button will be a component, a text area would be a component, a menu bar would be a component. Each of these components have a state. This is basically the internal data that resides in the component. This is actually private. It's not shared outside the component itself. And the component exposes some public properties. This is how you communicate with those components. So if I take an example here, I have a parent component. And this parent component may be inside another application, and it can also possess children. Now, the first thing you want to know is how do you communicate between a child component and a parent component? Well, you will pass data using the state of the parent to a property of the child. So the state is basically a variable, so it's one of the data held by the parent. So it will be passed to a child component as a property of the child. And on the way back, if the child needs to send data back to the parent, we'll actually pass a function that it belongs to the parent as a callback in the property of the child. So if the child needs to update the parent, it will call a JavaScript function that actually belongs to the parent. So this is really the basics. And there's also another interesting thing that I need to talk to you about in React, something called JSX. That's something that is pretty particular in React. That is, in fact, a JavaScript XML preprocessor. So that means you can write actually HTML or XML directly in your JavaScript code. The block of code here I'm showing shows how you can have a div with a React child component and some properties. Then it will use something called the random method to display my mix of HTML and React component. So this is JSX. We'll use that in the application. So I'll get back to that more in details later. Now, let's see how the application I showed you before is structured. I have divided the whole application into a set of components. Here you can see how they relate to the screenshot you have on the right. You have to note that the React app itself is a component. So although it doesn't have on its own a physical representation, a UI representation, it is something that holds all the components together, and it's actually where we'll have a bit of logic that can trigger the display between the different views, between, for example, the login panel and the query interface, where you can enter your so-called query. So now let's go a bit into the code, and let's see how this app component behaves. Here, I displayed the app component because actually this is where most of the logic happens. I'm showing you on purpose only one method of my component. That's the random method. This is what basically controls the view, and this is where the logic between the different states of the application will reside. The first thing that I have highlighted here is the navbar component. So this is a child component of my app. This is what actually holds the navigation bar. And you can see that there's a property called user, and this gets passed on the state of the app component. So if we are already logged in, then the user is the actual user connected to the application. If we're not logged in, there is no user. The navbar itself has a bit of logic, and so it will display the right view depending on whether we're logged in or not. So if I don't have my name on it, like here, that means I'm not logged in. But if I'm connected, I'll have my name displayed with the logout feature. Next to that, we have a bit of logic, a bit of interaction. So whether we're connected or not, we will display either the login panel view or the query form. What I'm using here is something called a ternary operation. So there's basically a Boolean statement here. So this state.user equal null, and then a question mark. So if this statement is true, we'll execute the first block. So we'll show the login panel component. And if the state user is not null, we'll show everything from the column here to the end. So we'll show the block with the query form component. Notice here that we have also a property on the query form component. We're actually setting up a callback. If you remember the previous slides, I've shown how you can interact between a child component and its parent. This is by passing references to methods. So the handle query execution is actually a method that the child component query form will call to trigger the execution of the query when you click on execute on the so-called query. And then after that, we're processing the result of the query. So if we have a result, we were showing the query result view. And if we don't have a result, we're not showing anything. So that's basically null. So this is how the different bricks, different components of my React application interact with each other. So this is fairly simple. Now, we're going to see how it interacts with the Node backend. So we see, again, all of our React components. And we're going to use a couple of HTTP endpoints on our Node app. First of all, there's a first type of interactions that it will have with the Node app, and these are not actually REST API calls. These are actually redirections, HTTP redirections. Why am I not using REST here is because I need to take control of the full view. So, for example, when I click login, I have shown in the example that we were redirected to an actual Salesforce login page. This is not part of our application, but it's part of the OAuth authentication flow. So here, the browser redirects me to a URL that is actually hosted by Salesforce. And I do have an endpoint here on my Node app, because the Node app will actually generate the right URL for me to redirect me to the actual URL hosted by Salesforce. I'll explain this more in detail when I cover the Node app. And same thing for the logout. We are also redirected to a different URL, and actually we'll go back to our React app on Heroku. Now, we do have some REST API calls. And these REST API calls are actually not performed by individual components. They're actually performed by the application itself, which controls the logic of performing the interactions with the form and with the force.com APIs. So the first one is actually called who am I. This is basically to get who is currently connected. That means that whenever I refresh my application, I'm able to see if I already have a session open so that I don't go through the authentication dialog. And the second one is actually the one that we're going to use to perform these local queries. So all of these endpoints will basically have some sort of interaction on the Node side with force.com behind. And I'll get back to that. So let's jump now to Node.js, the backend of our application. How does that behave? Are there people already familiar with Node.js here also? A few? Yeah, good. All right, so Node.js is generally a good companion for JavaScript applications. It's getting more and more popular. First, when I learned about Node.js, I thought it was only a server, but actually it's pretty much more than that. It is a runtime environment. So you could compare it to maybe Java or C++ or something like that. It's not always an HTTP server. It can do pretty much more than that. The advantage of Node.js is that it's running actually on JavaScript. And it's multi-platform. So you can run it on a Windows, on a Mac, on a Linux, whatever environment you have. It is also event-driven and asynchronous. So what that means is basically you provide handlers to different kinds of events. So that's pretty interesting when you have an HTTP server. And it can perform pretty well in terms of processing power. When you have a lot of load on it, it will react pretty quickly. The advantage also of using Node.js is that there are a lot of different modules and applications that you can use. In our particular application, we'll use two things. We'll use the HTTP server called Express. Express is one of the different options we have to handle HTTP requests. And we'll also use an HTTP client to communicate with force.com. So the HTTP server is actually listening to our React application, and we have an HTTP client which actually will be pushing data to force.com. That said, here's how it's laid out. We remember that we had those 4 endpoints on the left that will interact with our React application. And on the right side, this is where we'll have interactions with force.com. We have a first endpoint that will receive calls from callback from the authentication processed by Salesforce. And here I have another brick called a node module. That's actually a separate project that I've been reusing that will perform everything related to authentication and processing of queries. This is actually where we'll have the HTTP client that will call the force.com services. So if I go and have a look more in depth of the whole architecture in interactions between Node app and the force.com server, we'll see that we have our module that has 2 sub-modules, I would say. One is in charge of the authentication, so that part will process everything that is related to auth. That will take us across the whole authentication flow. And we have also another service that is actually mapped to a force.com services that deals everything related to the REST API queries running the SOCL query. So these are different force.com services. Now let's have something a bit more interactive. Let's see how we process the authentication flow. So I'm showing you that. That's something I did implement, but you can actually benefit from some of the Node modules that are actually existing in the community, Node.js community. For the process of this example, I recreated the Salesforce Node client library to deal with that, just to be able to understand the whole flow. The way it works is that our React application calls the first endpoint call of login. So that's when you basically click on login. It will redirect the view to a URL on the Node app. The Node app will actually call the auth submodule of Salesforce Node client. It will call the force.com service to get a URL to redirect the user to the actual authentication page if the user is not logged in. Also, on the first try, the first time the user actually tries to authenticate with force.com, I haven't shown you that, but there will be an authorization dialog, whether you want to allow the application or not to have access to your force.com profile. So that generates a URL. The URL is actually being sent back to the user. User actually inputs his login credentials, and force.com will actually send an HTTP request back to our application using the auth callback, and it will send an authorization code. Then, at that point, the Salesforce Node client will pick up that code, validate that it is correct, and hold a token that was also sent back by the force.com API. The token is actually what allows the user to perform additional REST queries, for example, to access data afterwards on the force.com server. The token is something pretty sensitive. It's something that should never be passed back to the client directly, so that's why we have a backend. The backend will actually store the session information of the actual user. It will never send back all of its data. So it will hold the OAuth token, and it will just redirect our app will have to redirect to the logged in view. So we've seen the whole scenario of the authentication flow. In practice, it is way simple. You don't have to worry about this part here, because all the 2, 3, 4, 5 are actually handled internally by the Salesforce Node client. Here I'm giving you the full story. Now let's see in terms of code how all of this is processed. So here I'm showing the code that is actually part of the application in Node.js. As I said, Node.js is event-driven. So here what we have is actually app is our express HTTP server. And it's actually responding to HTTP calls on this particular endpoint of login. So this is where the user is being taken when he clicks on login. That's the first step we saw in the previous diagram. Then in the lines above, we're generating an authorization URL based on the domain that in force.com that our app is hosted under. We provide a scope in terms of authorization about what we're going to access on force.com. And we redirect the user to it. So this is basically sending back the user to the logging screen that was hosted on Salesforce. After that, the user is able to perform queries, and this is this is the callback when the force.com answers back to the user after being authorized to log in. It will actually call the authenticate method from our Node.js module dealing with OAuth authentication, and it will reply with an authentication code. That means that the user is authorized to be logged in force.com. After that, what we'll do is we'll get the answer brought back by force.com. We'll save the actual token, so that's actually contained in the payload, allowing future requests on force.com. And would then let the user in the index page of our application. Right. So that's how this is processed. With like 10 or so lines, you're able to log in, and you're able after that to process queries on force.com. Now, how does that actually work? Now, once we have the application running on our server, on our local server, next step is actually to take it to the cloud. So that's the last component. We want to push that on Heroku to make sure that it is still in the cloud. Do we have Heroku users in the room? Yeah? Oh, good. Quite a few, yeah. All right. So for those who don't know what Heroku is, it's actually a company that is part of Salesforce, but it's a whole different product. Heroku is actually a cloud PaaS, platform as a service, and it provides different services such as runtimes, hosting. So it could host a Java application, it could host PHP application, or a Node.js application. It also provides some database services, so for example, Postgres or Redis for NoSQL. And it also provides interesting things, build pipelines or build tools. For example, you could run your continuous integration inside Heroku. And that's exactly what I'm going to show you guys now. So now that I created my project on my local machine, I needed to move forward to make sure it was on the cloud. The first thing I had to do was actually to push it to some source control. And here I chose GitHub because GitHub is actually connected to Heroku. So I created a small project. I will actually share the URL with you guys just after so that you can use it. I pushed my project to GitHub, and then I configured on Heroku an application. Inside that application, I created a couple of configuration elements. For example, I set up information related to my connected application in force.com. So these are the credentials that say that my application is allowed to log in and process data on my behalf. So you can see here, for example, the callback URL. This is actually the endpoint that Salesforce will call back after being logged in. And then you have some sensitive information that is specific to this application, the OAuth consumer key and the OAuth user secret key. These are things that allow us to authenticate on Salesforce. Once this is done, we connect Heroku with our GitHub repository. So we provide details so that it is allowed to be connected and allowed to retrieve our current code. And then we can decide either to deploy automatically or manually. So what Heroku will do is basically it will watch our repository for changes, and it will be able to deploy our application. We can either decide to do that automatically or manually. In my case, I did something very simple. I deployed it manually. But if you want to do something even more that will scale, you can attach actually some build instructions to run continuous integration build and to automatically deploy after passing some builds. So that was using Heroku. And now, for me, it's time to conclude. So during this session, I have presented the full path from actually building the front end to the back end to deploying our application in the cloud, running the basic use cases that we can have on force.com. We've covered authentication and running SQL queries. The overall project is pretty simple. Actually, there's not that much code. There are like maybe 300 lines of code. The most painful part when building such an application is actually taking care of the setup of the build environment in JavaScript. I did not show that on purpose because it's a bit confusing for people who are not new, to React and to Node.js. And the easiest part was actually deploying that to Heroku. Is just like I said, there's like 4 screens to configure and your application is on the cloud. So I really encourage you to take a look at that. Now, for those of you who are interested in this project, I've made this pretty documented so that you can reuse it. And the idea here is to avoid you the pain of writing down this OAuth chain and setting up the build environment. So I'm sharing with you guys the whole project here on 2 different repositories. The first one is actually the React application we saw, so that's the front end with the Node.js code. And also the reusable Node module that will take care of the OAuth flow and the SQL queries. Now, forward-looking statement, there should be a trail and trailhead about that in the near future. But forward-looking statement is not yet there. So make sure you follow. All right. So I'd like to thank you, and I will now take questions if you have any. Thank you. Any questions in the room? No, it was using Express. Buildpack, sorry, no. Yeah, it was using Webpack, yeah. And I use also Babel for the JSX compilation. Actually, I can show it. Now you have a bit of extra time. I can actually show the build setup. Oops. So this is what builds the application. So the way it works is that we have, on the server side, we have a server.js file. This is what will handle the different HTTP queries. It will also hold session data and process the different endpoints like the login endpoint or the callback. And on the client side, we have this app.js component, which is pretty simple. Here, it displays the different views by handling some AJAX queries to the Node.js backend. Any other questions? I really suggest that you give it a try on the GitHub. It's pretty well documented. And you have also the instructions on how to create the actual connected application in Salesforce. Just when I show it. Sorry, guys. So here I have added all the instructions if you want to learn about how you configure the project. This is what we're going to reuse to create the trail on Trailhead. Yeah. So just so that you know, there are other alternatives. People already had some Node.js modules to deal with the OAuth flow. I created mine so that I was able to control the whole flow and understand really all of it. But there are other alternatives to it. And this one actually has unit tests. I didn't unit test the React application, but the Node.js does have unit tests, so it's really following. It's actually using Travis CI to be tested, so it's more reliable. So the JS Force library is actually, yeah, it's another solution that could replace that.
But that's what cannot be supported.
There's no official support for it, for a library. Yeah. Here it's open source. Feel free to fork it. You can do whatever you want with it. So it would work with any version of the force.com APIs. I did it with the latest version, the 37, version 37 of the APIs, but it could work with previous versions too. Any other questions? Sure.
So does this library support the community use of API?
This is just really the REST login and OAuth using force.com, so it's not tied up to, yeah. All right. Well, thank you, guys.